Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are going to start our discussion on a new topic number 13, that is on human factors in extended reality. Before we start, let us quickly recap our learning so far. So, we talked about basic idea of XR, extended realities, issues and challenges. Then we talked about the hardware and the software that are typically used to build, develop, deploy XR systems. And we in the previous lecture also started talking about the idea of interactive systems, human factors and their relations to XR. So, we just gave some introductory idea. Primary concern in the previous lecture was on idea of interactive systems. Since in extended reality we put emphasis on interaction with the digital content. So, XR broadly belongs to the interactive systems domain, and the associated issues and challenges are to be addressed while we are trying to build and deploy an XR system. So, that was a crucial concept in understanding the foundation of extended reality systems, and in the previous lecture we started our discussion on that. We are going to continue our discussion on the topic of interactive systems and their relation to XR. In particular, in this lecture we are going to talk about human factors. Earlier we emphasized the role of human factors in interactive system development. Here what we will do is we will try to understand in a little bit more details the human factors that are relevant for XR or extended reality, and how the knowledge helps a developer build better XR systems. Now, before we start, let us quickly recap the working principle of the extended reality systems. On the one side we have the user, and on the other side we have the system. Now, the system we can view it as comprising of the hardware, the middleware which we are terming as XR engine, and the software or the application software. The user and the system interacts through input devices. So, user provides input and the system provides output to the user through output devices. The output that is generated are to be sensed by the user. Now, two things are important here. One is interaction design, other one is perceptual design. So, interaction design is important to give the user the ease of interacting with the system. Earlier we talked about such ease of use as usability. So, interaction design is very important to build an usable system which the user can interact with easily, and the output also is generated for the user to be appropriately sensed or understood or perceived. So, from the point of view of usability, both interaction design and modeling as well as perceptual design and modeling, one related to the input, other related to the output, are very important. The interaction and the perceptual stimuli, that is the output generated by the system, are supposed to be designed to create the best possible illusion of reality. Remember that our goal is to make a system that enhances presence. When I say it enhances presence, that means what I mean is that it gives us a sense of reality, as if we are in the real world. So, the interaction and perceptual stimuli are supposed to be designed to create that best illusion, best possible illusion of reality. It is not reality, but we are creating an illusion of reality. Now, this idea, of course, as we have mentioned earlier, is very crucial for VR, because here we are supposed to be totally immersed in the virtual environment to give immersive experience. Since in case of AR or MR systems, immersion is partial, we are still being able to view or experience real world. So, this illusion may not be very significant, but still not totally insignificant also. So, we have to think about how to create the best possible illusion of reality to give a better XR experience. So, that is our objective, to understand how to create that illusion. In order to understand that, we need to understand how our senses, how our perception works, and what is the physiology that drives our perception. So, let us try to delve a little deeper into our perceptual system. By now, it must have been clear to you the role of perception in our experience working with any interactive systems in general and extended reality systems in particular. Since the illusion of reality is primarily applicable to VR systems, we will mostly refer to VR systems while continuing our discussion. Now, VR refers to immersive experience, that by now we have learned. VR systems are supposed to be designed to have interactions that let us feel immersed. Now, this feeling is nothing but perceiving that we are immersed. But one important thing here to note is that by doing so, we are trying to fool ourselves. It is a kind of fooling ourselves in believing that we are in a different world. So, essentially what it tells is that we are trying to perceive the system as if we are in the regular, our familiar system. So, we are trying to fool our perceptions, perceptual process, perceptual system, to make us believe that we are still in our familiar system. Unless we are able to do that, complete immersion, complete presence will not come. So, our objective is to have as much presence as possible. In order to do that, our ability to fool ourselves should be maximum. The fact is that our bodies are not really designed for virtual reality, that is designed to perceive an artificial world, a virtual world. So, our bodies are designed, or our body organs are designed to perceive the world around us, which we call the real world. So, they are not designed to perceive virtual world. So, by applying artificial stimulation to our senses, what we are trying to do is we are affecting the biological mechanisms that have been evolved over a very long period of time in natural environment. So, our body gets trained to perceive real world based on not only sensory organs, but also experience, as we shall soon see how the physiology and the experience stored in long term memory combine together to give us the idea of perception. But when we are applying artificial stimulation, we are affecting that biological mechanism that has been learned over a long period of time, and how well we are able to fool that system decides how good the overall virtual reality experience will be. In fact, we are, by trying to do so, we are also providing input to our brain not consistent with our real life experiences. So, most of the times we will be doing things to experience virtual world which are generally not consistent with the way we do things in the real world given the same situation. So, generally we are sending signals that are not consistent to our real life behavior. So, if I try to do that, if we try to do that, what can be the potential outcomes of trying to do something which our body is not designed to process, which our brain is not designed to process? The potential outcomes can be there can be many potential outcomes. One is our bodies adapt to the new stimuli, make us unaware of flaw if any in the system. That means, we are adapting to the system, we are believing that the system is actually the real world rather than it is a virtual artificial system. Other possible outcome can be our bodies may not be able to adapt. So, body may react with increased fatigue or headache. So, some adverse effect can be seen on the body when we are trying to fool ourselves into believing that we are in the real world while actually we are in the virtual world. Now, this non-adaptation, as we have discussed earlier in one of the previous lectures, may lead to cyber sickness, that is dizziness, nausea, or a large set of different symptoms that we can experience while experiencing virtual reality systems. To design a good system or to understand flaws of a given system, we should have some understanding on how our perceptual system works. That is the crux of the matter. So, we need to understand the human perception for two purposes. One is to design a better system or to understand the flaws of a current system or a given system and improve or resolve those shortcomings. So, let us try to understand the human perceptual system. Now, there is a term called perceptual psychology. Many of you may have heard of this term. It is the science of understanding how the brain converts sensory stimulation into perceived phenomena. So, we have sensors, signals from real world comes to it, comes to those sensors, and those get converted into brain to perceived phenomena, and this process, the science of understanding this, is called perceptual psychology. It is always advisable to have a little bit knowledge on perceptual psychology while we are trying to deal with interactive systems in general and extended reality systems in particular. In fact, it is even more important in the context of extended reality systems, because here our goal is to explicitly extend our idea of reality, which is deeply embedded into our psychology. Now, there are several reasons why we should know perceptual psychology. In fact, these reasons can be understood in the form of some questions whose answers can come out based on the knowledge of perceptual psychology. For example, questions like how far away does the object appear to be in a given virtual world? How much video resolution is needed to avoid seeing pixels when we are trying to visualize a virtual world or a virtual object, how many frames per second are enough to perceive motion as continuous? Is the user's head appearing at the proper height in the virtual world, so that the point of view is ideally what should be the point of view with respect to the user's height? There can be some more such questions, answers to which can be found in perceptual psychology. For example, where is the virtual sound coming from? Why am I feeling nauseated? Why does one experience more tiring effect than another? Or in other words, why is one experience with a system is more tiring as compared to another experience? What is presence? In fact, perceptual psychology can give us a clue to the overall idea of presence. So, as you can see in the previous set of questions, what we have learned is that perceptual psychology in fact can give us some sort of guidelines in building better hardware as well as better understanding of effects of the system on the user. To answer these questions, what we need to know under perceptual psychology? Basic physiology of human body, including sense organs and neural pathways, how they are connected to the brain. What are the key theories and insights of experimental perceptual psychology? Interference of engineered XR system with our common perceptual processes and resulting implications or side effects. So, these are the things that ideally we should know when we are dealing with interactive systems. Of course, in this lecture we are not going to get into so much details. Those details in fact can be a course in itself, as you all may know. So, we are going to touch upon few basic things in perceptual psychology, particularly basic physiology and the insights of how the process of perception works. And also in subsequent lectures we will touch upon the third topic, that is interference of engineered XR system with our common perceptual process. So, let us first start with our understanding of perceptual physiology. So, we will start with a classification of human senses. What are the senses or sensory organs that we have, and what kind of things are there that allow us to sense. Now, when we are trying to understand sense or sensory organs, sensing in a sense, we should keep in mind that the term sensor can be used in different contexts. When we are talking of a device, a system, then the term sensor means a device to convert energy source into electrical signals in a circuit. In the context of human body, so human bodily sensors on the other hand refer to organ, a body organ, to convert a stimulus to neural impulses. Idea wise similar, structurally different. Now, let us have a quick look at the different sense organs that we have. So, we have vision sense, we all know. Now, in this case the stimulus is electromagnetic energy that falls on our eye. The receptor that is part of this sense are photoreceptors, and the sense organ we all know is the eye. So, when we talk of auditory sense, we have air pressure waves as the stimulus, mechanoreceptors are there, and the sense organ is ear. We have then the touch sense. Tissue distortion is the stimulus in this case, and we have two types of receptors here, mechanoreceptors and thermoreceptors, and the sense organs are skin, muscles. Then we have balance, sense of balance. In this case the stimuli are gravity or acceleration. We have mechanoreceptors and we have vestibular organs to act as the sense organ. Taste is there, chemical composition can be the stimulus, chemoreceptors are there, and the sense organ is mouth. Similarly, smell sense is there, again chemical composition can be the input, the stimulus, chemoreceptors are there, and nose is the sense organ. So, we have these 6 senses, out of which 5 senses are well known, and balance is a sense for which we do not have any specific organ, unlike the other 5. So, how sensing works? Now, each receptor is a sensor targeting particular stimulus. So, in the sense organ we have receptors, each receptor is a sensor that targets particular stimulus known as sensory system selectivity. So, receptors are bodily organs which are designed in a way such that they can get activated only when a specific type of stimulus arrives, and this phenomenon is known as sensory system selectivity. So, as we have seen there in the table that we just saw, our eyes contain photoreceptors. Now, these photoreceptors get activated when electromagnetic energy in the form of light, visible light, falls on our eyes. So, the photoreceptors are targeting electromagnetic energy in the frequency range of visible light. So, it gets activated only in the range of visible light. Auditory, touch and balance senses involve motion, vibration or gravitational force sensed by mechanoreceptors. Sense of touch additionally involves thermoreceptors to detect changes in temperature. Our balance sense helps us to know which way our head is oriented, or in other words including sensing the direction of up direction. Taste or smell, these two senses relies on chemoreceptors, provides signals based on chemical composition of matter on tongue or nasal passage depending on the sense. So, in summary we can say that we need to have some idea of perceptual psychology in order to understand the role of human factors in extended reality systems, and we also covered a little bit on a part of perceptual psychology, that is the physiology of senses. What are the senses that we deploy to perceive the world around us? We talked about 6 senses: vision, auditory, balance, taste, smell, touch, and for each there are receptors which are part of the sensory organs. The sensory organs are there, and in the organs there are receptors. These receptors receive stimuli depending on the organ. So, there are different types of receptors. We have photoreceptors, chemoreceptors, mechanoreceptors, and so on. In the next part of this lecture, we are going to talk about how the sensing process works. So, we now talked about the hardware of sensing in terms of human body, that is the sensory organs. Next, we will focus on how the hardware helps in perceiving the world. So, see you in the next part of the lecture. I hope you have understood the concepts. Looking forward to meet you again. Thank you and happy learning.